Hey everyone, welcome back to the channel Code with AKJ. Today is day 48 of solving Geeks for Geeks problem of the day, and today's question is nearest multiple of 10. So the question says here a string str is given to represent a positive number. The task is to round the str to the nearest multiple of 10. So if you have two multiples equally apart from str, choose the smallest element among them. So given two examples here, the string which is in the form of positive number, which is 29, and the nearest multiple of 10 for the number 29 is 30. And coming to the second example, the nearest multiple of 10 for the value 15 is 10 and 20, which is both are equally distant. So since the given problem expects us to return the smallest element among them, so we'll return 10. So they are expecting us to complete this problem in O of n time complexity and O of n space complexity. So let's try to understand this particular question by taking few more examples. So for example, if we take the value 25, the nearest multiple of 10 here would be 20 when we consider the leftmost, and the 30 when we consider the rightmost multiple 10. So the distance from 25 to 20 is 5 and 25 to 30 is 5. So since the distance here are equal, we need to choose the smallest multiple of 10, which is 20. So we return 20 from this case. So if you take another example, which is 33, the nearest multiple here would be 30 when we consider the smallest one, and the nearest multiple will also be 40 when we consider the round up higher value. So here the distance between these two multiples from 33 would be 3 and 7, and the smallest value would be 3. So the least multiple we can choose here would be 30. So the answer in this case would be 30. So let's start with the brute force approach. The idea is pretty straightforward. So since the given value would be in the form of string, first we'll convert the string to an integer and then check the two nearest multiples of 10. We'll compare the distance to the original number and return the smallest multiple if they are equally distant. So here the main task here would be to convert this particular string into an integer. So in C++ STL there's a function called string to integer which helps us to convert a particular string into an integer. So this particular function helps to convert a given string into an integer. So since our problem's constraint are up to 10 power 5, it may give us a runtime error, but still this is our initial thought and our brute force approach. So let's try to code using this particular function and let's try to submit it whether it gets accepted or not. So here's the brute force approach code where we initially convert our string into integer using stoi inbuilt function, and we'll store that particular number in num variable, and we'll find the nearest lower multiple of 10 by dividing by 10 initially and then multiply with 10, and we'll find the nearest higher multiple of 10 by adding the 10 to the lower multiple value, and finally we'll compare the distance with our original number num. So the absolute value of num minus lower multiple and absolute value of num minus higher multiple. So if the lower multiple value is less than the higher multiple value, then we'll return the lower multiple value. Since this value will be in integer, to convert into string as our function requires string as an output, we'll again use our inbuilt function toString, which will convert a particular integer into a string. So in this way, we'll compare these two multiple values by taking their absolute values from the original number, and we'll return that particular number into string according to their distances. And finally, if in case of tie, we'll return our lower multiple value. So let's try to compile and run this. So again, so let's submit. As you can see, it gives about signal or runtime error as our constraints are 10 power 5 and this particular function only handles integer values. So we need to stop using this particular function and we need to find another way, hopefully optimal way, to convert a string into our integer. So to solve this problem efficiently while handling large inputs, which is up to 10 power 5 according to our constraints, we need to avoid using built-in functions like stoi and toString. So that may cause runtime errors for larger strings. So instead we can process the string character by character to avoid converting it to an integer directly. So the steps here would be, so first what we'll do here is, instead of converting the entire string into an integer, we'll just work out with our last digit to determine whether we need to round up or we need to round down. So the rounding logic would be, if the last digit of an string is less than or equal to 5, we'll round down by replacing the last digit and any digits after it if necessary with zeros. And if the last digit is greater than 5, we'll round up by adjusting the string from the last digit backwards and handling any carries if needed. So for example, when a value is 99, since the last digit is greater than 5, we'll try to make this last character as 0 and we'll take a carry of this and we'll round up by moving backwards in this particular string. So here the edge case would be to handle large numbers. So numbers where rounding causes a carry like 99 for example, and numbers that are already the multiples of 10. So here the approach would be to traverse the string and analyze the last digit and determine whether to round up or round down. So if rounding up, we'll propagate the carry from the last digit backwards and ensure the solution handles strings of size up to 10 power 5 and without using any inbuilt functions. So let's try to code this approach and later on we'll dry run using a particular example. So here's the code for the optimal approach we have discussed. Here initially we'll take the size of a string, we'll get the last digit of the string, and if the last digit is less than or equal to 5, we'll directly round down and make the last digit as 0, or else if the last digit is greater than or equal to 5, we'll initially set the last digit as 0 and we'll take a pointer I which will move backwards and which will propagate the carry. So we'll traverse backwards until or unless it reaches the first character, and if suppose the value while moving backwards contains 9, we'll make sure that to convert it into 0 and we'll again move backwards. So until or unless we'll find 9, we'll try to make that particular digit as 0 and we'll move backwards. So if suppose we found a value which is not 9, we'll directly increment that particular integer. And if finally we'll reach our first index, which is I is equals to 0, we'll try to add the value 1 at the beginning of the string. So for example here, if the string contains 999, we'll start from index n minus 2 since the last index becomes 0, and we'll carry value 1 until or unless it reaches the 0th index. So we'll make this particular current value 0 and then we'll again move backwards, and since we reached the first index, we'll make it as 0 and we'll finally add 1 at the beginning of the string to convert this 999 to 1000, and finally we'll return string from this main function. So let's compile and run this. So let's submit. As you can see, this problem got solved successfully. So here the time complexity would be O of n and space complexity would be O of 1 as our expected time complexity and space complexity. So let's try to dig in more about this particular code by dry running these two examples and our edge case obviously, which is 999. So let's start with the string 29. So if our string is 29, so instead of converting this whole string into an integer as we have done in our brute force approach, we'll just consider our last index and we'll check whether this particular digit is greater than or equal to 5 or less than or equal to 5, just to round up or round down. So here the last character digit is 9, which is obviously greater than 5, so we need to round up this particular whole string and we need to find a multiple of 10 which is greater than or equal to this number. So since the last digit is greater than 5, one thing we can be sure of that we need to round up. And next step here, to make this value or the digit character set to 0, which is the last digit. So set n minus 1 index to 0 and we just propagate this particular carry towards backward while we loop backwards from this particular digit. So we'll take I value which would be start from n minus 2 after making the last index 0. So we'll check whether this index reached at the 0th index or not. So since it is reached at the 0th index and it is not value 9, so we'll directly increment this number with 1. So finally, after doing all these particular operations, our answer would be 30. So 30 is our answer in the case of 29. So again, next example here would be, which is 15. So we'll again take 15. We'll consider the last digit, which is 5, which is obviously less than or equal to 5. So we'll try to round down this particular string and find a multiple of 10, which is less than or equal to the number 15. So what we'll do here initially would be to just directly convert the last index to 0. So converting the last index to 0 gives us value 10, which is our multiple of 10, which is nearest to our main number 15. So let's take a little bit of bigger number. So we'll take again 156. So here we'll again consider the last index value or last character value, which is 6, which is obviously greater than 5. And we'll make our last index value 0 and we'll propagate that particular carry while moving backwards. So we'll start from here after making it as 0, which is 150. And since it is not equal to 9, and we'll directly increment this particular number with 1. So finally what we'll get as an answer would be 160. So the nearest multiple of 10 for value 156 is 160. And finally, let's take a bigger number and our edge case, which is 9, 9, 9, and 9. So again, we'll consider our last index, which is 9, and which is obviously greater than 5. So we'll round up this value by making the last digit as 0, and we'll again move backwards, propagating this particular carry. Since it is greater than 5, we'll make it as 0. And since this particular current index I is not at the 0th index and the value is equals to 9, we'll again make it as 0 and we'll move backwards. And again, since it is not at the 0th index, we'll make it as 0 and we'll propagate its carry backwards. So since it is at the first index and the value is equals to 9, we'll make it as 0, and finally we'll add 1 at the initial value of the string. So finally our answer after this whole number of operations would be 1000, which is our value 10,000. So nearest multiple of 9999 would be 10,000. So in this way our optimal approach code works. So here's the time complexity is O of n, as we are iterating over the whole string, and space complexity would be O of n, as we are not using any external data structure here. So this approach efficiently handles strings with up to 10 power 5 digit and without relying on any built-in functions. So that's it for today's video. We have explored how to round up a number to the nearest multiple of 10 using both a brute force and an optimal solution. So if you found this explanation helpful, don't forget to like, comment and subscribe for more coding problem explanations. Hit the bell icon so you can never miss an update. Thanks for watching, and I'll see you in the next one.